In this video, I'm going to be going through the Quiz 2 study guide, and I'm going to do each problem step by step. It would be my recommendation that you do these problems on your own before you watch these videos. Okay, for expanding and evaluating, so for these first two, you will have 10 minutes total to do both of those. For condensing question, you will have 10 minutes just for the condensing one. Okay. So for evaluating logs, remember, we are trying to figure out what this is equal to. What is this equal to? Okay, you can set it equal to question mark, x, whatever. We use the fact that we can switch between logarithmic and exponential form to solve these. So I'm going to do 3 to the what equals 6165, right? This is me using the property that says when we have log base b of x equals y, that is the same as b to the y equals x. Alrighty guys, so I had a little typo there I had to fix. I had 6165 even though it's 6561. So let's try this one again. When we have evaluating logs, again, we have to set it equal to question mark, right? We are trying to figure out what this is equal to. And when we set it equal to question mark, that allows us to change it to exponential form, and then we can use our math common sense and our calculator to figure this out, right? Math common sense would tell me that it's probably bigger than 3 cubed, right? 3 times 3 times 3 is not going to equal 6561. So I'm going to start in my calculator with 3 to the 4th. 3 to the 4th, that's 81. You don't have to show this work. I am simply showing it so you know, like, this is a video, you can't see my calculator, what I'm typing into my calculator. So I'm just going through, doing 3 to the 5th, that's still too small. 3 to the 6th, that's still too small. 3 to the 7th, too small. 3 to the 8th, bingo, 6561. So that means that our answer here is 8 because 3 to the 8th is 6,561. For the second problem here for solving, I'm going to again say, okay, this is equal to what? What is this equal to? That's what I'm trying to evaluate. So I am going to change it to exponential form. 1/4 to the x is 64. And now I have to kind of double fold use common sense here because I can't just plug this straight into my calculator because my guesses are usually going to be integers, right? I have to first recognize that this is a fraction and my answer is a whole number. So I have to think about what kind of exponents flips a fraction, right? Negative exponents do that. So I'm going to do a little sidebar where I'm really asking myself, okay, 4 to the what is 64 because I know that 1/4 to the -1 is going to be 4. So if I make it, it'll be 4 to the 1st. So if I can figure out 4 to the what is 64, then if I make that a negative, it'll flip the fraction. So I'll start with 4 squared, that's 16, 4 cubed, bam, that's 64. So because I know that 4 cubed is 64, that means I know that 1/4 to the -3 is going to be the same as 1/4 to the -3, which is the same as 4 cubed, which is 64. So my answer to this problem is -3. For expanding, I want you guys to remember the order that we do those in. So I'm going to write it down for us. The order that we go through our expanding properties is, or our log properties, is we start with the quotient rule. Then we do the product rule. Then we do the power rule. And I would recommend that before your quiz tomorrow or Friday, you have this written somewhere. Put it on an index card. Put the properties on an index card so they are easily accessible during the quiz. You don't necessarily have to memorize this. You just have to know what it means. So quotient rule tells us when we're expanding that we take division inside of a log and expand it to subtraction between logs. So I'm going to do that by going ahead and taking, got my numerator becomes 1 log, and then my denominator becomes my second log, right? That is what the quotient property is. When you have division inside of a log, you separate it into subtraction between the logs with your numerator in one log, your denominator in the next, okay? So quotient rule's done. The next property we use is the product property. The product property tells us that multiplication inside of a log expands to addition between logs. Now, I want to be very clear that this is not multiplication inside of a log, right? Because it also has addition with it. This is a single expression. Okay, I cannot expand 6x because it's not 6 times x plus 1, right? It's just 6x plus 1. That's its own expression, its own term. Here, though, where I have x squared times x minus 5, that can be expanded into addition. Okay, so my first part stays the same. That hasn't changed. There's no multiplication inside that log. And then this changes to natural log of x squared plus natural log of x minus 5. Okay, and then this is the trick. This is the tricky part of expanding. When we expand, if we were to condense it, we have to get what we started with, right? If you'd expand something out and then recondense it, you better get what you started with. For this one, to indicate that, we have to put brackets around this addition to show that, okay, yes, it is multiplied, but they are both being divided, right? 6x plus 1 is being divided by both x squared and x minus 5, which makes them multiplied in the denominator. If I didn't have those brackets there, I would end up, if I were to recondense, I would end up with this, right? The x minus 5 would end up in the numerator, which is not what we want when we started with. Okay, I like to leave the brackets there. Some people like to distribute in the negative, so they would write it, you know, like this. That's fine. You can do it that way. I just am a fan of brackets because to me it makes it really clear what's happening. Okay, so we've done the product property. Last is the power rule. I think this one is honestly the easiest. You just take any exponents that are on the entire argument of the log and bring them down out front as a coefficient, right? If I had like a square right here, again, I couldn't use the property on it. That is, the whole argument is not being squared, just the x's. So I can't use the property on that, but on this one, the entire argument is being squared, so I'll bring it down front as a coefficient. So my final answer, I'll have applied all the properties, will be as follows. And there you go. That is fully expanded. If I were to condense, I would go the opposite order, and I would end up with what I started with. So we are good. All right, let's take a look at this one. For this one, I'm still going to do quotient, product, power. However, there's no division happening here, right? Just like with transformations, if a step isn't there, you skip it. If it doesn't have any division in it, you're not going to be able to use the quotient rule. So we will skip over the quotient rule and go right to the product rule. Now, I have 3 things being multiplied together here, right? I have log base 7 of 3 times x times square root of 5x minus 1, right? That means each is going to get their own log with addition between them. So this will be log base 7 of 3 plus log base 7 of x plus log base 7 of 5x minus 1. I am going to rewrite it as an exponent, right? Because my next step, so that's what it would look like here, but my next step is the power rule. Bring down any exponents. And you may think this doesn't have any exponents. None of the arguments have an exponent. But we have to remember that roots can be written as exponents, right? Square root of x is x to the 1/2. Cube root of x is x to the 1/3, right? And so on. So we need to use that fact to rewrite, and I'm just going to do it right here, 5x minus 1 being square rooted as 5x minus 1 to the 1/2. Because then in our last step, when we use the product rule, since we have that one exponent, it can be brought down as a coefficient. And so this is our final answer here. All right, let's do one more expanding problem. Okay, this one is very, very similar to number 2 in the sense that we have multiple things in the denominator. However, there is an additional hiccup in this fact that the whole thing is being raised to the power of 3. You have two options of how you do this. The first option is you can bring the 3 down at the beginning. Now that blatantly violates our order of operations, right? Our order of properties. We go quotient, product, power. That order of operations, order of properties, only exists as a helpful guide. It's not like PEMDAS where it's written in stone. It is a helpful guide to beginners of using these properties. But technically, this 3 right here, it satisfies the power property, right? The power property says if you have an exponent on the entire log, you can bring it down. So you are welcome to do it like this if you so choose, okay? You just have to know that at the very end, once you apply all the properties, you're going to have to either distribute that 3 in or keep it outside brackets, right? You'll have all the logs and you'll need to have it in brackets like that, okay? My personal preference, because I like to do, I like to follow an algorithm, the order of operations, is that instead of bringing it down front at the beginning, I multiply it in, right? We know properties of exponents say, first they say, if you have x over y to the b, that is the same as x to the b over y to the b, right? We can distribute exponents over multiplication and addition and division. We cannot distribute exponents over addition and subtraction. So I multiply in that exponent. The other property we know is if I have x to the ab, right, x to the a to the b, we multiply those exponents. When you have exponents stacked, you multiply them. So this 3, I can multiply it in and then just do quotient, product, power, just like we did at the beginning. So this would become log of 4 cubed a to the 6th, right, because you have a squared cubed, which is a to the 6th, over b minus 1 cubed, and then c cubed cubed, you multiply them, is c to the 9th. Now I can just go through again and do quotient, power, product. Okay, so looking at that, I will take quotient rule. I've got a fraction, right? I have division inside of my log, so that can separate into log of the numerator minus log of the denominator. That's my quotient rule. My product rule says any multiplication inside of a log can expand to addition. So here I've got multiplication in the log, and here I've got multiplication in the log. Okay, so I'll have then log of 64, right? I just did 4 cubed is 64. You could leave it as 4 cubed. Plus log of a to the 6th minus, and again, I need brackets here to show that the whole thing is in the denominator, log of b minus 1 cubed plus log of c to the 9th. Okay? Again, you can distribute that negative in. You could have left it as 4 cubed. You would just have to now, when we use the power rule, if it was 4 cubed, you would have to bring down, make it look like that, bring down the exponent. But because it's just log of 64, I can keep it as log of 64. So we will have log of 64 plus, I'll bring down the 6, make it a coefficient, log of a, minus 3 log of b minus 1 plus 9 log of c. Okay, and then that is done. The other option, if you had pulled out the 3 at the beginning, right, and brought it down, your final answer would look like this. Okay, I'm just going to write this here in case anybody did it that way and they want to check the answer. Right, it's kind of like I just factored a 3 out of the answer above. Okay, both are correct, both are fine. Kind of just depends on how comfortable you are with the properties, what order you want to do them in. Okay, last but not least, we need to do some condensing. Okay, and this one actually kind of follows from the one we just expanded, where we have a couple things we have to adjust before we can actually put our answer into action. So let me real quick write down the order that we are going to use for condensing. It's the exact opposite of the order that we used for expanding. So the order for condensing is going to be, first you're going to do the power rule, then you're going to use the product property, then you're going to use the quotient property. But we have to adjust this a little bit before we use these properties, right? The power property is going to say anything outside gets brought up, any coefficient being multiplied outside of the log gets brought up as an exponent. But we have this 2 on the outside of everything. It's not on the outside of a single log. So I need to bring it up to each, and I'm going to show that by distributing it in, right? We have to simplify first. So I'll multiply the 2 in. That'll leave me with 2 natural log of x minus 1 plus 2 natural log of y minus 6 natural log of 6 minus 10 natural log of y plus 2. Okay, so I've taken care of that set of brackets, and now I need to put my own pair of brackets in. We know, or we should know, that by the time I get to the quotient rule, I should only have one subtraction sign. You should not start condensing a problem until you are left with just one subtraction sign outside of the logs, right? I'm not talking about this type of subtraction. I'm talking about the subtraction between logs. We cannot have both of these, because then when we get to the quotient rule, we'll end up with a triple-decker fraction, which is just not okay. So to account for that, we can do kind of the opposite of what we did here. Here, to account for 2 things in the denominator, we added brackets around the addition. What we're going to have to do here is add brackets to factor out a -1. So I'll put brackets here, and then this is going to turn into addition, right? Just like you can multiply in a negative, just like if I started with, -2 times x minus 1, that's going to be -2 plus 2, -2x. I can also factor out a negative, divide out a negative, and say, oh, okay, if I take out a -2, it's going to leave me with x minus 1. Okay, so that is what we're going to do so that when I get to the product rule and the quotient rule, I can properly do them. Okay, start with the power rule. Okay, power rule says any coefficient in front of the log comes up. And because we had that 2 on the outside, it's going to go up to all of them. Okay, now some of you may be thinking, well, why can't I just put the 2 up here? Well, we know that's not how exponents work. Exponents cannot be distributed over addition. So putting an exponent on this, it's not going to be the same as putting an exponent on each individual one. So we distribute it in first so we can see, okay, this is going to all of them. Okay, and remember, for the quiz, some of you, as you've practiced more and more, may be getting more comfortable with the properties, which is good, but you still need to show your work, right? To earn credit for the problem, I need to see the steps. I need to see the work. There should be at least 3 steps. You should go through the power step, the product step, the quotient step. Okay. Next up is the product step, and we have 2 sets of addition. So both of those, I'm going to take the arguments and multiply them. For both of those, I'm going to take the arguments and multiply them. So we will have natural log of x minus 1 squared times y squared minus natural log of 6 to the 6th times y plus 2 to the 10th. Okay. We've done the power rule, we've done the product rule. Last but not least, we need to do the quotient rule. Whenever you get to the quotient rule, you should always just have two things left, right? Because we've said the first one's going to become our numerator, and the second one, when we condense, is going to become our denominator. So we'll do just that. We'll have a big natural log. It's going to be a gross looking fraction, but we'll have x minus 1 squared times y squared over 6 to the 6th, which you can simplify that if you want, but you don't have to, times y plus 2 to the 10th. And then this one is fully condensed. This one, there is nothing special in the beginning that we have to worry about, right? There's not two things being subtracted. There's not any weird coefficients. We can just go through and do our order of properties. So the first thing we're going to do is bring up both of these coefficients. So when we do that, we'll end up with log base 5 of y minus 3 plus log base 5 of y squared, right? We're bringing up that coefficient as an exponent, minus log base 5 of 4x squared plus 1 to the 1/3. Okay, so that is the power rule done. Next, we'll do the product rule that says when we have addition between logs, we can condense that to multiplication inside of the log. So that'll be y minus 3 times y squared, and then subtracting this one stays the same. Okay, you are able to leave this as an exponent. If you wanted to, you could change it to a cube root, but I'm okay with you leaving it as an exponent. And then lastly, we need to change this to division using the quotient rule, right? The quotient rule says when you have subtraction between logs, you can condense it to division inside of a log. So this first one will be our numerator, and the second one will be our denominator. And we're done. All right, for this final one, you are able to do these in order of operations, but you'll end up with something a little tricky if you do that. Because notice there are no parentheses here. There are no brackets saying, hey, we need to do these all multiplied together. So we would actually kind of work left to right. So the first thing I'm going to do is rearrange this into a way that makes most sense to me, that I feel best about using my properties. Just like if you had 4 minus 6 plus 2 plus 1, you could rewrite that as 4 plus 2 plus 1 minus 6. Right? Those are the same things. Right? We're still subtracting 6, we're still adding 4, 2, and 1 together. I can move that minus log of x minus 2 to the end of the equation. So I'll have 1/2 log of 4 minus 3x plus log of y squared plus 9 log of 5 minus y minus log of x minus 2. Now I can apply my properties in order. So first we will bring up the exponents. So we'll have log of 4 minus 3x to the 1/2. It was already up. Okay, I was like, did I do it? Nope, it was already up. Then this will be to the 9th minus log of x minus 2. So that is our power rule. Now we'll do product rule. We have 3 things. This is the first one where we have 3 things being added. Oops, I just scrolled. This is the first one where we have 3 things being added. So all 3 of those things are going to become multiplied inside of the log. So we have square root of x times y squared times 5 minus y to the 9th minus log of x minus 2. Okay. Now, last but not least, we can apply the quotient rule, which again, we should only be applying it when we have two things. Okay, that's going to be the easiest way to do it. Okay, so that's because our first thing will become our numerator, and our second argument will become our denominator. And now this is fully condensed. And we're done with the study guide.